Hello, everyone. Thanks for joining us today here. This is a kind of technical talk. It's very close to my heart, however, because before I became a DevOps guy, I was a software engineer for many years, and I was very passionate about DevOps practices and ownership, and I always had open-ended questions. How can these things scale in a much bigger engineering team? So this talk is dedicated to my younger self, and hopefully it gives a glimpse of how we're doing things in GWI. So yeah, a few things about myself. I'm head of DevOps at GWI. I'm very passionate about automation and about DevOps culture. So a few things about what we will talk today. After this very short intro, we'll talk about Terraform. We'll introduce infrastructure as code and talk about the ecosystem around it. We'll talk about Atlantis. We'll talk about OPA and infra cost. We'll try to see the bigger perspective and not be very dive deep into technical details. All right, but I hope you like it. So, what is Terraform? I promise I'm not going to spend a lot of time on it. This is not a Terraform presentation, okay? But you need to understand what is Terraform before we jump into the rest of the presentation. So at DevOps, as part of a DevOps team, we also always talk about infrastructure as code. And one of the toolkits when we talk about it, it's Terraform. So Terraform, it's nothing more fancy than a wrapper around the cloud, APIs around the cloud. So GCP has some APIs to create databases and VMs, the same with Azure, the same with AWS, and Terraform is just a wrapper above those APIs. The only thing you need to know about Terraform for today is that it has two commands. Terraform plan, if you give it configuration, it will tell you what it will create. And Terraform apply, it will actually call the APIs and create this thing for you. Now, just to be perfectly clear, every cloud provider has its own implementation of infrastructure as code. Terraform is not the only one out there. We prefer Terraform because, for a couple of reasons. First of all, it does not lock you in a certain provider. You can use Terraform for GCP, and then you can switch relatively easy to AWS. But also with Terraform, you can achieve multi-cloud. Again, it's not exactly how it's being advertised, but it's not impossible. So yeah, only two things we need to know today about Terraform. It has two commands, Terraform plan, and then Terraform apply. And Terraform has a declarative language. It's JSON-like. It's very easy to read. You don't need to be a Terraform expert to be able to read this code over here. If we need right away, it's very easy to describe what it does. All right, it just calls a Terraform module and it creates a GCS bucket for us. Just a bucket in GCP. The code is very easy. You just need a name, some roles, storage class, location, some permissions, and that's about it. So if we take this piece of code and we add some init commands and we run Terraform plan, Terraform will say, you know what, I will create this bucket for you. If we run Terraform apply, it will go on and it will actually create the bucket. But again, this is not a talk about Terraform. We don't talk about Terraform this time. It's about engineering culture. How can you make your engineers have ownership and think like DevOps without having a very big DevOps team? In fact, this is how we managed to scale in GWI. From the beginning, we had a very small DevOps team. We are still small, but we have an engineering team of almost 100 people. And we actually follow Spotify's guild model. We have a DevOps guild. And every engineering team has one or more DevOps champions, engineers who are familiar with Terraform and with cloud, at least enough to be able to own part of the infrastructure. So the smaller DevOps team is mostly there for guidance and support and for more technical stuffs if things are needed. And this has worked very well for us. We have a GitHub repository called Infra, and teams can go there, and those DevOps champions are responsible for owning all of it together. And for the first few years, it has worked very well for us. Okay, we're talking about a DevOps team of 1 or 2 persons max, with an engineering team of 30 and scaling up to 200. Okay, it has worked very well. So some obviously very good points. We were able to move very fast. There was no dependencies between teams. Knowledge was be able to share a lot. And I don't know if you're like me, it's very often for engineers to jump into DevOps. So that way we could justify, people could, could satisfy the DevOps needs. So they did not have to change role or change company. They could still stay and pick up some DevOps responsibilities. However, some things were kind of bad, because people were not Terraform experts. They were very often copy-pasting Terraform code. If someone was doing something nasty, it was very often the case, loads of bug practices to be across the repo. It was very difficult to have processes around it. And because everyone was owner of this repository, DevOps could not very easily get the ownership back. But some things were very bad as well. The most obvious one is infra is fragile. Back then, engineers were running the Terraform plan and Terraform apply commands locally on their own computers, which means people could bring down clusters, destroy databases, bring down completely projects. And we were assuming good faith, but we knew that if we were not doing something about it, things could be very bad very quickly. Because everyone was running stuff locally, there was no history as well, and it could not scale because there were conflicts between teams using the same resources. But we will mostly focus on the good stuff. All right, what we had, it was working very well for us for a few years, and this is how we managed to scale without the need of hiring loads of people, train them, and stuff like that. Okay, so it worked very well for a while. So what we will do now, we'll start introducing some services that will help us solve the issues we were talked before. And if you're familiar a bit with how services are working, the main problem here is people were using local commands to run stuff. So by centralizing the Terraform commands, you'll see how we'll be able to solve most of those things. Now this is where we'll introduce Atlantis. Atlantis, in its essence, is also something kind of easy. It means that it's a service, it runs in your cluster, so instead of having people locally running Terraform commands, you just ask Atlantis to run it for you. Atlantis, it's an integration with GitHub, so it lives in your cluster, it is integrated with GitHub, so it listens to Terraform PRs, and then the only thing it does is runs plans or applies for you, and then it pastes the results to a GitHub comment. It's easier to see it here in practice. So this is a PR. Someone created a very short PR. It's a Terraform null resource. It's nothing, just an empty resource, mostly used for housekeeping. And here Atlantis picks this up, says, you know what, that's fine. I'm going to run Terraform plan for you, and this is what I will create. Just an empty resource. I can so create the PR. Atlantis says, this is what I will create, and then I ask for a review. Someone goes, reviews my very complicated code, gives a thumbs up, then I'm happy. I ask Atlantis to apply this thing for me. Again, Atlantis, it's not something fancy. Underneath, it gets the Atlantis apply and runs the Terraform apply for us. And then after running the apply, it just pastes a comment of the results. Have created the null resource for me. Everyone is happy. The PR is happy. The reviewer is happy. The author is happy. Closing the PR, and that's it. So let's see what we have managed with only this introduction of centralizing the Terraform commands. We managed to solve most of the bad things. All right. Best practices, consistency, history, and scalability somehow have been taken care of us because we're introducing code reviews. People now can see code, and it's not up to a single engineer to apply stuff locally on their computers. We can review code, we can ask for changes, and because Atlantis is replying back with the state, it's very easy to go back 3 months in an older PR and see what was the state of the cluster when we ran Atlantis apply 3 months ago. Before that, it was impossible. So yeah, unfortunately, we have introduced some even harder dependencies. Because Atlantis has now the ability to create whatever we ask it to do, it means it's completely powerful. It has the ability to do whatever I want. So if I create a PR and I bring down a cluster, I don't even have to wait for a review. I can ask Atlantis to apply, and then everything will go down. Again, we assume best intentions, but again, it's very easy to bring down your production cluster. So we have introduced some nice stuff, but some things could be better. And now it's time for the second iteration. If only we could find a way to create some policies, some processes around Atlantis, so Atlantis can do some stuff, but it's not permitted to do some other things. And this is where we'll introduce policies with OPA. Actually, I think it's called OPA for Open Policy Agent, but I'm Greek, I'm going to call it OPA, it's fine. So OPA is an open source engine for enforcing policies. It has a language called Rego. Again, it's a declarative language. OPA and Rego have nothing to do with Terraform. It can work with any framework, anything that can be JSON. But because Terraform, you can export stuff as JSON, it works very well for it. And you've guessed it, it has a very good integration with Atlantis as well. Actually, now we will not focus on OPA or Rego because it's a huge topic. It's completely its own presentation. But in order to continue, we'll assume that the integration with Atlantis is completed, and we have one policy, okay? The simplest policy we can think. And that's it. The policy is, we have a null resource that we created before. Let's say no null resources are allowed it here. So we have Atlantis, we have a policy that does not allow null resources. This is how it looks like. Here, again, we have the null resource. Atlantis says, "Ooh, I'm just going to create this null resource for you." But we have a policy that restricts it. Then Atlantis runs the policy and says, there is a failure. You have created something that was not supposed to happen. But, I'm an engineer. I don't care. I'm just going to try to see what's going to happen. I try, apply, and Atlantis fails because one policy failed. And this minor change, this second iteration of having policies around infrastructure as code, actually it's huge. It means that some of the oldest problems, people bringing down clusters, bringing down databases, or even projects, now it's just one policy away. What's going to happen if we restrict engineers? Then everything, suddenly, it's closer to where we want this to be. These are some of the examples, some of the custom policies we have built in GWI. Nothing very complicated. We don't want people to delete certain stuff, like databases, clusters, and stuff. This is a very good way if you want to enforce labels in your resources. For example, we want all of our clusters to have an environment or a team dedicated to it. And you wouldn't be surprised knowing how many engineers, they just omit this kind of stuff. So this is a very good way to centralize it. We also want to deny access on certain buckets that we don't want engineers to have. Also, we don't want people to start abusing certain Terraform modules that they are not up to date. And also now we started as well enforcing some ports and ingresses, anyway, stuff that you don't want people to use by copy-pasting code. All right. And, it's working. It's working very, very nicely. It's working actually so nicely that people don't even complain, because most of the times, they don't even notice that policies are running behind the scenes. But there is one more step, okay. If we talk about ownership, we know at GWI that people can have ownership and they can take care of their Terraform code. But when we talk about cost management, people are abusing the system. You can imagine, when you have stuff like that, when adding one more node, adding more memory or more CPU is just one PR away, and your PAL can apply, your PAL can review. It's very easy to abuse the system. And by the end of each month, having your cloud bill getting up and more and more. So from my experience, talking about ownership, you need to talk about cost management as well. Engineers, they need to be owners of their budget. Otherwise, eventually people will start abusing the system, and then you'll start talk about cost effectiveness. So what is the next thing we'll introduce is called infra cost. It's not the only solution, there are other stuff out there as well. And again, it's an easy concept. So every cloud provider has some APIs to tell you how much things cost. And infra cost, it just looks for PRs and takes your changes and say, oh, you know what, these changes will cost this amount of money. And then it posts back results into GitHub. This is a very good example. Here, our friend Alistair, he created a Terraform PR, and then he added 1.5K per month to the monthly bill. That's a bit tough. I'm not surprised, but Alistair may not know, may not even know how much this will cost. Most of the times, engineers are asked to apply this kind of stuff or figure out ways to have stuff run faster, and most of the times you can achieve this by adding better infrastructure. But now Alistair knows. He knows that these things cost 1.5K. So if he comes back and says, I don't know, I didn't know, now he has responsibility. And now he has ownership. Okay, responsibility, it's a bad term. Ownership, it's a much better term. Okay. So yeah, this is infra cost. Again, it has nothing to do with Terraform, not that much at least, or with Atlantis, but it still is not where we want to go. We have added policies, and now we have infra cost, so you can see where it's going. Wouldn't it be nice to combine policies with cost allocation as well, and say to my friend Alistair, you know what, Alistair, you can do whatever you want, but please don't exceed 10% of this monthly cost. With OPA and with Rego and with infra cost, this is possible. So this is just one policy away. And this is what we're doing. We have written our own policies that are led by the teams themselves, and you can add limits in your stuff, in your Terraform code. So you can have stuff like, you know what, I don't want this database to exceed this amount of money every month, or every PR will not exceed this amount of money per quarter, stuff like that. You can be very creative. And by giving them this ability, like ownership over cost, suddenly engineers, they have almost complete ownership, okay? Because we have infrastructure as code, and you have DevOps champions, and these DevOps champions are responsible for infrastructure and for cost and for monitoring, and they cannot control and they cannot act uncontrollably because you have policies in there as well. Right, so a lot of things that I have said. Let's take a step back. What we had at GWI almost 2 years ago was engineers locally creating stuff. And it was fine, but people start abusing the system. So we had 3 iterations. The first iteration was centralized everything, so people could not bring down the whole production clusters. Then we start adding rules on top of it, policies that we kept expanding, and actually OPA policies, we took the open source road, but most of the cloud offerings out there, they offer something similar with OPA and Rego. I was having a look at Wiz yesterday, which is a security toolset. They support out of the box more than 200 policies. The same applies with Terraform Cloud, again, because this is where the community goes over the last years. Okay, we're not the only ones who have this kind of problems. And the third iteration we took was just give them, cost. It's up to them now. Okay, they can control their budget, they can review their budget, they can ask for more stuff, but we as DevOps are responsible for having some processes around it. Okay, so they cannot completely abuse the system. And that's, younger Dennis, how we managed to scale from 20 engineers up to 100 with a very, very small DevOps team, 3 to 5 people over the last 4 years. Thank you. Just in time.
much, Dionysi. I said we have 2 questions from the audience. First question, do you suggest individual DevOps resources to be allocated within each agile team or having a central DevOps team handling all the requests and serving multiple teams?
It's challenging to reply that. For us, it's working fine, having a centralized DevOps team that we just help once in a while. So the DevOps champion thing has worked very well for us. But it may not be for everyone, okay? It needs a specific culture. So sometimes it's just easier to allocate DevOps resources than change the company culture. So it's mixed.
Okay, thank you very much. Second question, what is your opinion about transforming the DevOps team to an internal developer platform team?
Okay, I don't have an opinion on this. It depends of how big your team is. Personally speaking, it's difficult to get good DevOps engineers. It's also difficult to embrace this culture because you can always throw more resources, throw bigger teams to the problem, and somehow it's going to be fixed. For me, culture, it's an ownership. It's very critical. And that's how we manage to scale without worrying that much about splitting resources or splitting the DevOps team or have a platform team or have an SRE team. Because ownership is very strong in the engineering department. If that was not the case, eventually we would also have to grow the DevOps team bigger and essentially introduce SRE and introduce platform and stuff as well.
Thank you very much.
Thank you. Hope it helped.